Hello, and welcome to today's lesson on constructing ray diagrams for real images produced by a convex lens. Today we will firstly introduce lens ray diagrams. We will then learn to construct ray diagrams for real images from convex lenses. So far, you are familiar with the features of lenses and real and virtual images. Let's get started. Ray diagrams are crucial in understanding how lenses form images by illustrating the paths taken by light rays. Though light rays are refracted at both surfaces of a convex lens, we will simplify our diagrams by assuming that refraction occurs only at the center of the lens. In practical applications, light rays can come from all angles, but for our diagrams, we will only need to draw 3 rays to predict the image location accurately. For clarity and simplicity, we'll use 3 specific rays whose behaviors we can easily predict. Firstly, the parallel ray. This is a ray that travels parallel to the principal axis before it enters the lens. This ray will refract and pass through the focal point on the opposite side of the lens. Secondly, the central ray, which travels straight through the center of the lens without changing direction. Finally, the focal ray travels towards the focal point on the same side as the object before entering the lens. This ray refracts and travels parallel to the principal axis on the other side of the lens. Using these rays, we can construct a precise ray diagram to determine the location and nature of the image formed by a convex lens. Let's break down the steps for constructing a ray diagram for a real image formed by a convex lens. Step 1. Draw the principal axis. Start by drawing a horizontal line representing the principal axis of the lens. Step 2. Draw the convex lens. Then place the convex lens at the center of the principal axis. The lens is often represented by a line with 2 arrows. Step 3. Mark the focal points. Once this is down, we mark the focal points, F, on either side of the lens. These focal points should be at equal distances from the center of the lens. Step 4. Draw the object. We then represent the object using an arrow placed above the principal axis and to the left of the lens. Make sure the object is positioned beyond the focal point. Step 5. Draw the parallel ray. Next, draw a ray from the top of the object parallel to the principal axis. Once this ray passes through the lens, it refracts and passes through the focal point on the opposite side of the lens. Step 6. Draw the central ray. Then draw a ray from the top of the object straight through the center of the lens. This ray will not change direction as it passes through the lens. Step 7. Draw the focal ray. Following this, draw a ray from the top of the object towards the focal point on the same side of the object. After passing through the lens, this ray will refract and travel parallel to the principal axis on the other side of the lens. Step 8. Locate the intersection. With these rays drawn, identify the point where these rays, the parallel ray, the central ray, and the focal ray, intersect on the other side of the lens after refraction. This is the location of the real image. Step 9. Draw the image. At the point of intersection, draw the image of the object. Note that the image will be inverted or upside down compared to the object. To summarize, start with the principal axis and place the lens and focal points accurately. Draw the object beyond the focal point and use the parallel central and focal rays to locate the image. The intersection of these rays on the opposite side of the lens will determine the position and nature of the real image, which will be inverted. In today's lesson, we delved into constructing ray diagrams for real images produced by a convex lens. We started by understanding the importance of ray diagrams in visualizing how lenses form images. We simplified our approach by focusing on rays that either travel parallel to the principal axis, pass straight through the center of the lens, or head towards the focal point before entering the lens. We outlined the steps to create a ray diagram. Starting with the principal axis, we placed the convex lens at the center and marked the focal points on either side. The object was positioned beyond the focal point to predict the formation of a real image. We drew the parallel ray, central ray, and focal ray from the top of the object, observing their refractive paths through the lens. The intersection point of these rays on the opposite side of the lens indicated the location of the image, which was found to be inverted, watch the rest of the GCSE physics course at Sophos Education.